Okay, we're going to have a think now about the factors that affect the distance a vehicle stops in when the driver, for example, sees something on the road in front of them and hits the brakes. So, stopping distance is made up of two parts. There's the distance that you travel whilst you're reacting to whatever you've seen on the road, and we call that the thinking distance. So, for example, human reaction times are around about 0.2 of a second. If you're travelling at 10 metres per second, 10 times 0.2 gives you a thinking distance of 2 metres. But you've still got to actually stop your car. So when you hit the brakes, the car will slow down, but it won't stop immediately. So as well as the thinking distance, there's the braking distance. So let's take an example of this kind of situation. So here we are, we're going to be travelling along in our car. And maybe we see something on the road in front of us, maybe it's that tortoise or something, and we've got to stop the car quite quickly. So, we're going to travel a certain amount of distance whilst we're thinking about what to do, and then a certain amount of distance whilst we're actually braking. And this bit over here, the thinking distance, is easy to work out. The thinking distance is just equal to the speed of the car multiplied by the driver's reaction time. Okay, thinking distance is just speed times time. So if you're travelling faster, it's going to be a bigger distance. Also, if you've got slower reactions, it's going to be a bigger distance. And this is a common exam question: what kind of factors might affect your reaction time? Well, it'll depend on if you've been drinking, whether you've got drugs in your system, that would affect your reaction time. It can be affected by your age. It'll be affected by whether or not you're paying attention to the road. You're going to react more slowly if you're not concentrating. So those factors would affect your reaction time, and obviously the speed at which you're travelling will also affect your thinking distance. Now, what about the braking distance? This bit's a bit trickier, because here you're hitting the brakes and the car is slowing down. If the car's slowing down, we can't just use the straightforward formula distance is speed times time, because the speed is changing. So how are we going to calculate the braking distance? Well, let's have a think about what's happening in energy terms. The energy that you've got when you're travelling is mostly kinetic energy. So we know a formula for that: half times the mass times your speed squared. Kinetic energy. Where's that going to go? Well, when you hit the brakes, you're going to do work. There's going to be a braking force, and force times distance is equal to work done. And if you think about it, work done is a measure of the energy that's changed, the energy that's transferred. So you've got to do as much work as your initial kinetic energy. You've got to get rid of all that kinetic energy. You've got to transfer all that kinetic energy into sound and heat. Maybe a little bit of wear on the tyres as well, a little bit of wear on the road. All of that energy, all that kinetic energy has to be lost. So you've got to do a quantity of work equal to your initial kinetic energy. So we know that half mass times speed squared will be equal to the braking force multiplied by the braking distance. That's just an application of the formula work done is force times distance. So if I rearrange that a little bit, we're going to, I'll just rub this out into some more space, we're going to end up with a formula for braking distance. Braking distance equals half the mass times the speed squared divided by the braking force. So what's going to make a difference to the braking distance? Well, the equation tells us a larger mass car, all other things being equal, will have a bigger braking distance. A higher velocity and higher speed will give you a bigger braking distance. If you've got really big, can exert a really big braking force, that will make the braking distance smaller. So things like the quality of your brakes, the quality of your tyres, the condition of the road surface as well. If you are on a very slippery slope, it's going to be difficult to get a grip, so the braking force on average will be smaller and the braking distance will be larger. So you can see that that formula quite nicely explains the main variables involved in braking distance. One other point about it, by the way, notice that the braking distance is proportional to the square of the speed. That's quite important because that means that when you double your speed, the braking distance doesn't just double, it will go up 4 times. So the difference between someone travelling at 30 miles an hour and 60 miles an hour, in terms of braking distance, the braking distance will go up by a factor of 4. 4 times more metres are going to be needed if you double your speed. And that's one of the reasons why, from a road safety point of view, keeping a good distance between you and the car in front of you, car behind, is so important.